Saxon Advanced Math Lesson 58.A. This is distance from a point to a line. And we're going to start with, I just put up here a point and a line, and we're going to talk about the distance between them. If I just talked about distance in general, it's a little bit confusing because I can very easily say, well, there is an infinite number of distances between the point and the line. Am I talking about from here to here, or here to way down there somewhere? But as I get closer and closer to this line, there is exactly one line that is the shortest distance away. And that shortest distance happens to create a perpendicular line to the original line that passes through the point and the line itself. And so when we're using this, when we find the distance from a point to a line, what we're really looking for is the shortest distance from a point to a line. So what is the shortest distance? What would be the closest point that the line ever gets to this line here? And that will be this point right here. So we're going to look at 58.1 to begin with. And it says find the distance from -3, 5 to the line y equals 1/2 x plus 1. I went ahead and graphed these two. So I graphed -3, 5 and then graphed the line y equals 1/2 x plus 1. And when I look at those two, I realize that I've got a positive sloped line and I've got a point that's not on that line itself. Well, how far apart are these? Well, I'm going to find this out by taking and looking for the line that's perpendicular to this line that passes through this point. So then we're going to work these out with really easy steps. First thing I need to do is I need to find the slope of this line. Well, the slopes of perpendicular lines, because they're right angles, by definition they make a perpendicular, are negative reciprocals of the original slope. Well, my original slope is 1/2. My equation of line y equals 1/2 mx plus b. So y equals 1/2 x plus 1. 1/2 becomes -2. So I flip the 1/2, making it 2 over 1, and then I put a negative sign out front. So my new slope is -2. So y equals -2x plus b. I'm ready to use this, but I also have to have a point to define where this line is. The good thing is I have a point, -3, 5, that this line is going to contain that point. So I go ahead and plug that in. 5 is my y, -3 is my x. If 5 equals -2 times -3 plus b, so 6, I subtract the 6 from both sides, and I end up with -1 equals b. If -1 is b, I can plug that into my partially created equation here and say y equals -2x plus 1. Once I have this, this is the equation of this line. This is the equation of this line. So I have the two lines, and where they cross, the x and the y will be on both lines. So the next thing I do is I set the two lines that I have equal to each other. So y equals mx plus b and y equals mx plus b. So I use my little bit of substitution and say y equals 1/2 x plus 1 and y equals -2x plus 1. So -2x plus 1 equals 1/2 of x plus 1. And I start to simplify this down. I get x is -4/5. Once I know that x is -4/5, I can take this and plug it into either line. Both lines would give me the correct answer. So -4/5 in for -2x plus 1. And that gives me y as a +3/5. Once I know that, I have a point. I have this point right here. Now, my graph is not perfect, but if it was perfect, this point would be at a -4/5, and I've got it about -1, and my y would be up at 3/5, and I have it almost right on the line. So I'm pretty close on my graph for estimation there, but my point is here and here. These are my x and y. So now if I could find the distance between those 2 points, right? Because this is the point that's on the line perpendicular to this other line. If I could find the distance between the 2 points, I would have the distance between the point and the line, or at least the shortest. So how would I find the distance? Well, I use the distance formula. And that's just a Pythagorean theorem in disguise. So I plug this in, -3, 5, -3, 5, and -4/5 and 3/5. And remember that it's x1 minus x2 squared plus y1 minus y2 squared. And that's going to give me negative makes it a positive, so -11/5 and a 22/5 when I find my common denominators. I square it, 121/25 and 44/25, add them up, end up 605/25, and I end up with the distance being 11√5/5. Now, this is great, but that doesn't tell me distance very well. Sometimes the exact answer is not the best answer because the exact answer in this case has a root in it, and I don't think well in roots. So if I work this out or simplify this, I end up with 4.92. Once I realize that, I'm saying this is 4.92 away. There'd be a quicker way to get to this. And so if we back up to here and we say, well, since we're going for the decimal anyway, forget about finding all of these common denominators and squaring fractions and finding the root of fractions, and we can just jump right to plugging in my calculator. -3 plus 4/5, -2.2, 5 minus 3/5, 4.4, and this gets a lot easier for us as humans working this because our calculators do a wonderful job of squaring 2.2 and 4.4. And now I'm looking at just a couple of decimals, I'm adding them up, 24.2, find the root, it's still 4.92. Notice that these gave me the same answers. This is a lot more difficult for us to work because we're squaring fractions and stuff. And since we're coming to an end that is going to end up as a decimal anyway, because I'm not going to find this in simplified radical, there's really no reason to do that, I would suggest getting to this point and then just start using that calculator, right? Start plugging in those values, and it's going to give you the correct answer of 4.92. So to recap what we did, we find the new slope. So we have the original slope. On this example here, my original slope was 1/2. I found the new slope, which was -2. Then I find the equation in the new line. Well, how do I do that? I use y equals mx plus b, and I plug in my new slope and one of the points, my x and y point, to find my new b, and that gives me the equation in the new line. Then I set the original line that they gave me and the new line that I have, which is here, equal to each other. So I set them equal to each other to find the second point. The fourth step then is I find the distance between the 2 points. So I found the point that's on the line and the point that's not on the line. And then I use the distance formula to find them. And the distance between the 2 points will be the same as the shortest distance from the point and the line itself. And this works every single time. All you have to do to find this is know that the equation of a line and the point that is not on that line. And you can find the shortest distance between them using this method.